Today we're taking a look at the last of our rules for differentiation for taking derivatives, and it's called the chain rule because stuff is connected this time. So for chain rule, we use this when we see parentheses, whether those parentheses are imagined or not, or we actually see them or not, and we'll see that in a second. These are mainly used for groups with exponents, for roots, when there's a long equation inside a square root, for ln functions, for trig functions. Now the actual chain rule itself, let's see. Alright, so using the chain rule, the derivative using the chain rule is f prime of g of x times g prime of x. Alright, so I'll highlight this just like as before when we did product rule and quotient rule. There's a pattern to follow. Alright, so let's describe this a little bit better here. Now a g of x, this piece here, is the inside. Alright, so when we were talking about parentheses earlier, g of x is the inside of the parentheses. Now f of x, and I'll put it separately over here, f of x is the entire group. Alright, so let's put this to use and see what happens here. So for example, we want to find the derivative or differentiate the following. Y prime equals parentheses 3x squared plus 6x to the 5. Now if we took this back to other days, this does not mean that that exponent 5 gets distributed to everything inside. No, we got a polynomial inside. What this really means is you have to write it out 5 separate times and then multiply that parentheses out every single time, and that's a lot of work to do. It's possible, just a lot of work. So what we're going to use today, since we see the parentheses, is chain rule. Alright, so see my parentheses here? We're going to use chain rule. And I'll write that chain rule from above. Is f prime g of x times g prime of x. So what we're going to do, basically this whole entire thing here is f of x. The inside is g of x. So the outside is f, or the entire thing is f, the inside is g. So what we want to consider this as is we're going to take the derivative of the outside, keep the inside how it is, and then take the derivative of the inside. So watch me as I do this. What we're going to do is consider this whole thing. There's something inside, right? It happens to be g. But if I think of it as something else, there's something inside and it's to the 5th power. Let's go ahead and take the derivative of that. That means you take the 5 forward and then down by 1. So that's this part here. Think of that inside as x, just one thing. Let's bring the 5 forward and then down by 1. So finding the derivative of this so far, 5 comes forward, we have something inside, and now the exponent should be 4. But let's leave that inside alone. Remember, see, I'm not changing the inside, so keep it as g of x. So the inside stays as 3x squared plus 6x. Okay? Now we're going to multiply it by this piece over here, the derivative of the inside. So now we're looking at the inside, and let's take the derivative of that. So we're going to ignore this 5 out here. Let's take the derivative of the inside. So this would be 6x to the power of 1 plus 6x just becomes 6. Okay? Now, we can clean this up a little bit more. We notice that everything here is connected by multiplication, so the order really doesn't matter. So I can switch stuff around. Take the 5, put the 6x plus 6 here, because now I can multiply this out, it's still going to be multiplied by this 3x squared plus 6x to the 4th, but we're not going to write all that out because to the 4th power, that's just way too much stuff to write it out 4 times. So at least we can clean up the front. We've got 30x plus 30. That whole thing is being multiplied by this 3x squared plus 6x to the 4, and that's really as far as we're going to go right now. That is the derivative of that original piece using chain rule. All right, so it's basically derivative of the outside, or derivative of the whole thing, keep the inside. Multiply it by the derivative of the inside. So this time, let's find the derivative of square root 6x squared plus 5x. Everything's inside that square root. Now this time, we still are going to use chain rule, because one of our little stipulations up there said if we have something inside a square root, a long equation inside a square root, we're still going to use chain rule. Because technically, yeah, parentheses here. We can rewrite this. See, it's in radical form right now. We can rewrite this into exponential form. And remember, square root is the same thing as exponent 1/2. And now this looks kind of like that one before. We've got a polynomial here with an exponent outside. Exponent just happens to be a fraction. And remember, we're going to use f prime, keep the inside, times the derivative of the inside. Okay? So, we're going to do this part. So y prime equals 1/2. And then moving that down by 1, so 1/2 minus 1 is a negative 1/2 power. We keep the inside in this one. So 6x squared plus 5x. Keep the inside. But we're going to multiply this whole thing by the derivative of the inside. So now let's only focus on the inside. 2 times 6 is 12. X to the 1 power. And 5x, taking the derivative of that, is just 5. All right. Now we do have ways we can clean this up, and we're going to go ahead and do that. Remember, everything here is being multiplied. One of the issues we're going to have eventually is this negative exponent. That's going to have to move down to the bottom. But right now, let's rearrange this. Take 1/2, move this piece kind of forward. 12x plus 5. Move that other piece back a little bit. Okay, because now I can take this 1/2 to both of those. So we're just cleaning it up here. So we got y prime equals 1/2 times 12x is 6x, plus 1/2 of 5 is just 5/2. That's the best we can do there. Now the other part, remember, we don't want, oops, I forgot it there. It is negative 1/2. We don't want negative exponents. The way we get rid of that is moving it to the bottom. So this whole thing moves to the bottom. 6x squared plus 5x. And now this 1/2, when moved to the bottom, becomes positive. All right. And if we really want to, oops, this is derivative. And if we really want to clean this up a little bit more, instead of having the 1/2 power, we can write it back as a square root. Make this look a little bit cleaner. 6x squared plus 5x, all inside a square root. All right, so multiple ways of looking at this as the final answer. Kind of the important part here is using the actual chain rule in this step here. And then after that, we're just cleaning up the answer as best we can. All right. Let's try another one of these. So, for example, let's find the derivative of another. Let's go back to a simple polynomial, this time with 3 terms inside. All right, so using chain rule, because we have exponents outside of parentheses. So remember, this moves forward and then moves down 1. So y prime, 4, keep the inside, x squared plus 5x minus 3, and now the exponent moves down to a 3. Multiply this to the derivative of the inside. So we've got 2x plus 5, and that 3 disappears. Rearrange terms a little bit, or just know that I'm going to really multiply the 4 to these things over here. So y prime equals, we can keep the order, or change the order. 4 times 2x is 8x plus 20 times x squared plus 5x minus 3, and then that part's to the third power. Okay? So let's get a little funkier here. Let's get into our trig functions. So for example, let's find the derivative of cosine of tangent x. Now notice this is different. Now I'm just going to make a note over here. Previously we had cosine x, tangent x. The difference here is that x. That's what the cosine is of. This time you see there's no x there. The tangent x is representing what's inside cosine. So this is built into each other. So this is a chain rule that we have to use here, where this whole thing is f of x, and this piece in here is g of x. Alright? So remember, not this one happening. We need to do f prime of g of x, see that's the inside, times g prime, derivative of the inside. Alright? So, what we're basically doing here, I need to take the derivative of the outside, you keep the inside the same. So the outside part is really cosine. So the derivative of cosine, if we think back, is negative sine. We keep the inside the same. Tangent x. We multiply that by, so we've done this, we need to multiply it by the derivative of the inside. And the inside is tangent. And remember, the derivative of tangent is secant squared x. So there's really not too much we can do other than dropping the parentheses in our final answer. So we've got negative sine. Actually, no. I kind of like the parentheses, so because that tells me that's the inside. So really, I'm sorry, there's no real changes to make to this one. There we go. So we're just following the pattern. Take the derivative of cosine, keep the inside the same, and then multiply it by the derivative of the outside. Let's see one final example here. This one mixes both trig functions and some numbers. So y equals sine, I apologize, come on, sine 6x to the fourth. So it is a trig function. It's not sine x times 6x to the fourth. It is sine of 6x to the fourth. So we don't see it, so go ahead and put those imaginary parentheses around there. So really, we would like this to say sine of 6x to the fourth, and then that makes us feel a little bit better about this because now we have an inside and an outside. The full thing is that the inside is 6x to the fourth. Okay, so let's take the derivative of the outside. So y prime, derivative of sine is cosine. We keep the inside how it is, 6x to the fourth. We multiply that by the derivative of the inside, and remember this is the inside. So 6 times 4 is a 24x, 1 lower to the third. Now you may be tempted to multiply these two things together, but you can't. This 6x to the fourth is part of the cosine. You can't really multiply this. This is a constant number, so we're just going to move that to the front. That's all we can do. So take 24x to the third, and that's being multiplied by cosine 6x to the fourth, and that's the best we can do. Alright, so again, big thing for today is following the pattern for chain rule. go back to it. So, derivative of the outside, keep the inside, multiply it by the derivative of the inside.